اوكي، بسم الله. قلنا نبدأ في المثال رقم 3-4 في صفحة 79، ومعطيك الفيكتور A. خلينا نشوفه هنا. معطيك الفيكتور A given two displacement vectors A with a magnitude of 8 meters A 8 meters, direction 45 degree, below the positive x-axis. خلينا ندير الاكس والواي، اكس واي minus y minus x below the positive x-axis like that. It's 45 degrees. Let's make it like that. 45 degrees. Okay. A is 8 meters, making 45 degrees below the positive x-axis. And B, which has an x component of plus 2 meters and y component is plus 4. It's 2 here and 4 plus 4 in y, and let's make it here. This is the 45, okay? And here is plus 2. Okay, this is the B. Find the vector C. What's the value and direction of vector C so that the word so that بحيث أن. Okay, A plus B plus C is equal to vector D that has a magnitude of 6 meters. D has a 6 meters in the y direction. This 6, okay. This here, the vector D. Okay, let's see how to get the vector A first. The value of A is equal to square root of AX square plus AY square. Okay? AX is equal to A cosine 45, okay, which is 8 cosine 45 degree. AY is A sine 45, okay, in the negative direction, because this is here, This is A, x and the positive. And now this here, A, Y in the negative direction. Okay? Okay. This is here AX, and this is here AY. We can say this is the value here. I don't know, you calculate it here. And this here, if we say this is the circle. Okay? Okay. And B, now we have A. Okay? B, vector B has 2 in X, that's how, is equal to 2 in X plus, this is plus here, 2 in X and 4 in Y. This is Bx. Bx plus By is equal to 2 plus 4. Okay? Then B is equal to square root of 2 square plus 4 square. It's already given in the values here. Okay, let's see what is C. They want C, okay? C, or the value of C what? We have D here. D is equal to dx plus dy. Dx is 0, dy is 6, okay? Then D, the value of D is 0 square plus 6 square. 36 is 6 meters. Now we apply here for, we put the value of A, okay, plus value of B plus value of the equation here is A plus B plus C is equal to D. Or C is equal to A plus B minus D. Okay? Sorry. C is equal to, I'm sorry. Here, C is equal to D minus A minus B. Cx is equal to dx minus ax minus bx. Okay? And we have here dx is 0 minus ax is 8 cosine 45 minus bx. Okay, bx is 2. Okay, bx is 2. Now, okay, you just take this. I don't know. It's 45. 8 is equal to minus 1 over square root of 2 minus 2. Okay, cy is equal to dy minus ay minus by. Dy is 6, okay, minus ay minus this figure here, minus 8 sine 45, okay, minus by which is Vy, which is 4. C is equal to square root of Cx square plus Cy square. It goes with angle of tan minus 1 Cy over Cx. Okay, we'll see that the projectile also in 2D. This is the x, and this is the y, and the projectile goes this way first. Okay. It goes with the V0. This is the V0 at the direction of theta. Okay. We analyze this here like in x and y. The same we say in x and y. And here y this and x like that. It goes here, find y is small, x will be the same. In here, Vy is equal to 0, and Vx, this one here. It goes here, Vy, something that, but Vx keep the same. In here, Vy, Vx will be the same. As we see that Vy starting fast, then slow down, getting to 0, then starting to change the direction, okay, up to get to here. But Vx, V is equal to Vox, okay, because in x direction the velocity is constant. What mean? That means A is equal to 0. Ax is equal to 0. The projectile or the ball or whatever projected affected by the gravity, okay, while the gravity, because it's free, the ball is free here, okay, whatever comes here, it's free in the air, which is affected by only the gravity of the earth, while in x direction the g doesn't affect on the ball or projectile. Okay, let's see other things. We have here at this point this is y maximum. At y maximum, okay, Vy is equal to 0, okay, and Vx is equal Vox. as always the same velocity. Okay. In this case, what's the time? Say v is equal to v0 minus gt. Okay. Vy, okay, v0 is equal to 0, is equal to vo minus gt, and here is t is equal to v0 over g. Okay, this is at y maximum. Okay, let's see in the x direction. Okay, it's vxt. Okay, vx is the same v0, is equal to v0t, is equal to v0, take t here, v0 over g. Okay, that will be v0 square over g. X here at y maximum, where that this is x. Okay, which is the halfway, another x here. Okay, and this flight time, okay, is twice. For example, we call it range. The range is from the flying point up to dropping point here. It's equal to 2x. Okay? That means is equal to 2v square over g. And this we call range. Vox. Okay. Vox is equal to VO sine theta. Okay? VO sine theta. It's very important because we say here, this is the this is the theta, VO cosine theta, VOY is equal to VO sine theta, cosine theta. And here, VO cosine theta. This is the VY and this is the VX. Okay. Let's take example. When I give numbers, then it will be free. Free of these things, but let's make it like that. This is the VO, VOX, VOY. VOX, and this is the theta. Okay, VOX is VO cosine theta, and this here VO sine theta. Okay, where is at? This is the highest point. Okay, at the highest point is Vy is equal to 0. Okay, this is y maximum, and we say that Vy is equal to VOY minus GT. Vy is equal to VO sine theta minus GT. This, we say this is 0, and then this is VO sine theta minus GT, and T in this case is equal to VO sine theta over G. Okay? Okay. Now we have the an x direction. X. This is x up to y maximum. X at y maximum, okay, is equal to, at y maximum is equal to VO x t. VOXT. VOX is VO cosine theta, and T we say VO sine theta over G. Okay? In this case we say that VOT is VO is equal to VO square cosine theta sine theta over G. Okay, this is the x at y maximum. The range is x, okay, 2x. Range is equal to 2x, okay, is equal to 2 VO square cosine theta sine theta is sine 2 theta over 2 cosine sine theta is equal to half of sine 2 theta. And this is very important to know. Okay? And I'll take the values here is equal to 2 v square, 2 of this value, 2x, okay, 2 VO square over G, and we'll take this value, which is sine 2 theta over 2, which gives you V square, VO square over G sine 2 theta. Okay, this is the range, the flight distance. Okay, we'll see here sine 2 theta. The maximum of sine 90 degrees is 1, and this is the maximum. Sine 89 is less than 1, and sine 91 is less than 1. Okay? if we got the maximum range of a projectile when sine 2 theta is 90. That's mean sine 2 theta is equal to 90 degrees, then theta is, say, sine 90 degrees, then theta is equal to 45 degrees. When theta here is equal to 45 degrees, this gives you the total, the maximum range of the projectile. Less than 45, okay, is less than, for example, here, this is when the projectile here, when the projectile is more than 45, will come in here. Less than 45, maybe will come here. But when it's 45, it goes the maximum range. Okay. Okay, this is the projectile. I'll stop here, and then we'll continue tomorrow. We'll see. Now at the projectile here, the motion in two directions. Please make sure that when they say the maximum height of projectile is going in two directions, x1, x and y, okay? And VO, it has VOX, which is constant all the way. Then we don't have any acceleration, okay? And this is applied for x, about here. X is VOXT. Has nothing with it to do with the plus half of acceleration times square, because A is 0, then this is the law here. We got the time here from the maximum height, okay? And the time of flight will have the time here up to the maximum point. The same thing is T1 and T2. T1 plus T2 is the maximum, or the flight time. Hope you follow up the videos. Try to solve the problems like examples. Solve it first and see how can what's your solution compared to the solution in the book. First of all, you think both the given values, then what you need to find. Nothing is complicated. There are something I need you to know, that at the constant velocity, acceleration is 0. At the highest point, V and Y, okay, Vy is 0, okay, because the projectile wants to stop like V0 and then will change the direction. What other things to get? The maximum range when the angle is 45 degrees. This is the maximum. This some points, you know, because the exam will be MCQ. MCQ, it has to you have to think before answer. You don't have, for example, they will say, okay, the maximum range when it's the angle is 48 or 35 or 45 or so. Then we have here the maximum range is at 45 degrees. We'll say, for example, in the x direction, the acceleration is 9.8, like g, or in the free air, or for example, or 0 or so. And then you have to know that in the x-axis, in the x direction, the velocity is constant. That's why we call the we say the acceleration is 0. Okay, let's give you, because I ran out of the charge here, but we'll talk about now Newton's law. Okay. Okay. Newton's law, talking about the force, mass, and acceleration. And the mass m, when I put anything just on a table, okay, we have the forces should be, there is no movement, then the sigma x, sigma fx, sigma fy, okay? This must be 0, no movement, and this must be 0, no movement. In the x direction, we don't have any force, okay? In the y direction, we have the weight, which is mg, okay, and the fn or n. This is very important. This is the normal force, or the fn normal force, or n, as we say, normal force. You have taken that like ردة الفعل, okay? Very important. The normal force is very important factor. Why? Because first of all, we say the normal force, okay, Fn, is perpendicular to the surface. Whatever the surface here, with an angle theta, normal force deals with the surface here, okay? Making angle theta, normal force always perpendicular to the surface. And this is important. But the weight is down like that. This is m, the weight, mg, okay? Okay, in this case here, we said sigma y f0, what's sigma fy? This is in positive y, negative y, positive y, okay? Fn minus mg is equal to 0. In this case, Fn is equal to mg. Okay? If we have force F, which is in the direction of x, okay, and this is here direction of y. That's why I said Fy, sigma Fy. In case of this force takes the mass in acceleration like that. that will be F is equal to MA. Okay? But let's make the forces are equal, or the body is at equilibrium the same, remember when we said, talking about the vectors, okay, this is x and y, and if the force, if this way, and then you have fx, and we have fy. Very important. This body here, mass, okay, is hanged with here and hang it here. If this makes, for example, 45 degrees, okay, and here is making for 37 degrees, okay, here. Okay, this is, we call it the tension. This is T1, and this here T2. T is tension. Okay. What we have, forces. Okay, let's take the forces here. And we have, first of all, mg. And at this point here, okay, we have mg down. What's the weight? Okay. We have here we have to analyze this. This here, T2 cosine 45, and here is T2 sine 45. The same thing here, we have T1 cosine 37, and we have here T1 sine 37. Okay. Now, as we see here, let's make, there is no movement. It's hanged, anything hanged. Sigma fx, the word sigma is the sum. Here, sum, what's the sigma? Sigma fx is equal to 0. No movement. Okay? And sigma fy is equal to 0. Because the body is not moving either in the x direction or in y direction. What we have in the in the x direction, we have here T2 for cosine 45 positive, and negative here we have minus T1 cosine 37. Okay, we have nothing else. No, this force here and this force here is equal to 0. Okay. For sigma fy also as 0. The body is not moving in the y direction, then it's 0 here. What we have here in the positive, we have T1 sine 37 plus T2 sine 45 minus mg is equal to 0. Okay? And for T1 and T2, any unknowns. We have one unknown then we have one equation. If we have two unknowns, we have two equations. Three unknowns, three equations. Otherwise, cannot be solved. Then we have here number 1, number 2. Because we have unknown of T1 and T2. Okay? Say T1 and T2. They gave us only, for example, 10 kilograms, for example, and the G is 9.8. And we can solve this, you know. I'll show you how. If we say that T2 is equal to the other side here, T1 cosine 37 over cosine 45, that will give you a value, and this value, I don't know what's the value here, but it's T1. Okay? Take here T1 sine 37 plus T1, the result of T1 here, okay, sine 45 minus, for example, 10 kilograms times 9.8, okay, is equal to 0. Then you can say, you'll find that the value of T1. And then you apply this for T1 here, it gives you the T2. Okay. T2, it has to be in the x direction and y direction. Okay. T1 also, it has to be in x direction and y direction. Make the summation of in the direction of x. Okay. This is the positive, this is negative. While here in sigma y, this is positive and this positive, and this is the negative. Okay. Let's see that F is equal to MA. Now we'll make the movement of this, and we'll take also the frictional force. We have two kinds of frictional force. Fs is a static frictional force, and Fy and Fx and Fm are Fk, okay, kinetic. We said the kinetic. Then we have, let's see this mass here and mg and Fn. Okay, this is F, and here there is no friction, frictionless. Friction, frictionless. Friction is the احتكاك. Less is no friction. ما فيش احتكاك. Frictionless, then it moves like that. A. In this case, sigma Fx is equal to Ma, which is F here, is equal to Ma. Okay. Sigma Fy is equal to 0 because the movement in the x direction. Move in x direction. Okay? No y direction, there is no movement in y direction. Then it's Fn minus mg is equal to 0, or Fn is equal to mg. Okay? This is frictionless. Let's make the same here, but the force is M. The force is F, making angle of theta. We have here mg. We have here Fn. In this case, we have the force, okay, the force like that, which is making theta. We have here Fx, and we have here Fy. Fx is equal to F cosine theta. Fy is the F sine theta. In this case here, the A in this direction. We say that sigma Fx moving in x direction has acceleration, okay? Is what we have here is Fx is equal to max, or F cosine theta is equal to ma, okay? Sigma Fy is equal to 0. There is no movement in here. We have Fn plus Fy minus mg is equal to 0, or Fn is equal to it's plus F sine theta minus mg is equal to 0, and we can solve for this. Okay, then we have here always sigma Fx, sigma Fy. And we see, is the body or the mass moves in the x direction or in y direction. If it moves in x direction, not y direction, is sigma Fy, as we see here. Okay, let's make some other forces like friction. Frictional force. This is the frictional force, rough surface. Okay. And we write the frictional force like that. Fs. Fs is the static frictional force. What's static frictional force? That's hold the mass to move. Okay, hold it. It's another force. This F in the direction of x, y, x. The mass is not moving in x, then it's 0. Okay? I'll just tell you something, maybe it helps you. This is we say Newton's law. If the body is not moving, the mass is not moving, then A is equal to 0. If the body is moving, then A has a value. Okay? The body is not moving in x, that's mean A in x is 0. Okay? What we have in x? We have F on the positive direction minus Fs is equal to 0. From here we have that F is equal to Fs, static force. sigma of y is not moving, then ay is 0. Okay? Fy, what we have here, Fn minus mg is equal to 0, or Fn is equal to mg. Okay. Also, if we have that f has an angle, okay, f is with an angle, whatever the angle, theta is a value, 45 degrees, 30 degrees, 37 degrees, 93, whatever, 39 degrees, whatever, okay? Then this is the f, then we say this is fx, and here fy. In this case, we say sigma fx is not moving, then ax is 0. Okay? What we have here, we have fx minus fs is 0. Fx is f cosine theta minus fs is equal to 0. Okay? Okay, let's see that fs is equal to f cosine theta. Sigma fy also is 0. What we have in fy, fn plus fy minus mg is equal to 0. Fn plus f sine theta is equal to mg. Okay. Now the body is not moving. What about if it moves? It moves, that means, okay, let me take this. I'll make another, make things clear instead of how to know where the in which direction the mass is moving. Okay, then I'll give you that sigma fx is equal to max. Sigma fy is equal to may. If the mass is moving only in the x direction, okay, then we have ax. And this here will be 0. Okay. The other way, if the body or the mass is moving in the y direction, like elevator, okay, the elevator, l'ascenseur, okay, l'ascenseur or the elevator is moving only in y direction. Then in this case, we have y and we have this 0. Okay, this is elevator. Elevator. Okay, the elevator is moving only in y, either y or minus y. Then a y, we have it. A x is 0. But if we have a car, okay, a car, the car is moving and they either minus x or plus x. Here ax has value, ay is 0. This to simplify the things. And if the mass is not moving, It has no acceleration in x, no acceleration in y. Okay? All right. Then we talked about Fs. There is no movement. In x, 0, and in Ay is 0. Ax is 0, Ay is 0. But let's move the mass on a fraction or rough surface which has fraction. Okay? When the surface has fraction, we call Fk. Okay? Then let's take this. We say here Fk, which is kinetic frictional force. Kinetic. This is static, this is kinetic. That means the frictional force due to movement. Here, let's say this mass m goes with F in this direction, A, X, okay? And here, this is the rough surface, which is frictional force of kinetic frictional force. We have here the mg, which is the weight, and we have here the Fn. The word n here is called a normal force. Of course, you have taken in the secondary school or primary school, whatever, the normal is saying عادي. But in this case here, normal is perpendicular. The word normal is perpendicular to the surface, wherever the surface. It's inclined with any angle, theta. Okay? In this case, we have sigma Fx is equal to max. In this case, x has a value. Okay? And sigma Fy is equal to 0. There is no Ay here is equal to 0. It's not moving in the y direction. What we have in x? We have, this is a plus, and the plus x, and this is in minus x. Minus Fk is equal to max. Actually, we'll give you the acceleration, which the body is moving with it, and the mass of the acceleration. Of course, the force or whatever. In this case here, we say the frictional force reduced the force with an amount, and we'll see how to calculate the frictional force. Okay, the frictional force. Frictional force, either static or kinetic. We have that factor called ms or mu k. Okay, this is the factor of the friction, the surface. This surface, for example, has either, this is mu k, and the others we have, when we have fs, we have that mu s. Okay? The frictional, static frictional force, it has the mu s of Fn, a part of Fn. Okay? In this case, Fn is equal to mg. Then if we have the factor here, okay, it's equal to ms mg. Then you can calculate the fs. The same thing here for Fk. We say the kinetic frictional factor Fn. Okay. Then we say we can calculate the frictional force, static frictional force or kinetic frictional force, if we given that the factor of the surface mu s and mu k. Okay, I think let's make also other values. We'll take about the elevator. Okay, the elevator. Okay, here the mg, all mg for the man and the elevator, mg here. Okay, and we'll say the elevator is moving this way. Tension, of course, tension, because the elevator has a rope or whatever is hanged. That's why we say with tension. The tension gives the elevator up and down. Okay. In this case, AY has a value. AX is equal to 0. We say we apply the same thing. The tension up there, the weight is down there. Then, if it goes like that, A, Y, okay? In this case, A, we say not as positive or negative. If the S in the direction of the movement, we'll also give example for the movement in X. Okay. We have the only here we have G. Okay, then this is due to gravity, and G always minus, negative is negative. A is here positive. Okay, let's see. I don't know if we have this in the book, but let's talk about the apparent weight and the real weight. Let's talk about a mass of M1 hanged to a mass M2, okay, in this case, and no movement. AX is equal to 0, AY is equal to 0. In this case, what we have? Equilibrium here. This is here M3G, here M1G, here M2G. Okay. What we have here is T2, T1, T1, T2. Okay. And we have here the Fn. And these two masses, we don't have Fn, because Fn is dealing with the surface on which the mass is standing on. Okay? And we have only this surface. This mass is standing on this surface. There is no surface here to stand on, no surface here is to stand on. Okay? We say that the system is not moving. The system is not moving. What we have here, not moving, then sigma fx is equal to 0, the same as sigma fy is equal to 0. Make this like routine. Okay? We'll see that sigma f is equal to ma. Then sigma f x is equal to m ax. Sigma fy is equal to m ay. And we'll see in which direction it moves. Now the system is freeze like that. There's no movement. What we have fx, we have t2 minus t1, that's it for this, is equal to 0. We don't have other force in the x direction. I have only this 2. Okay, this is number 1. We have also, for example, sigma fy is equal to may is equal to 0. What we have force here? Well, let's see here first. Okay? We have T1 up plus y minus y minus m2 g is equal to 0 here for this body. We're talking about from here to here. What do I have also? Okay, this is number 2. Number 3 we have with this value here, say T2 minus M3G is equal to 0. This is number 3. Okay, we have this T2 and T1 and this T2. Remember that this is the reel here, okay? This is the reel. Has only one rope, okay? Then the tension here and the tension here in the same rope here. The same tension. Here also, the same tension here. Okay? And we solve for T1 and T2, whatever. We have that T2 is here is equal to T1, and then will be all the system in equilibrium. Okay, let's move this mass. Okay, let's move this mass here. If we move this mass here, x this way, okay? We have also here ay. We have here ay. What will happen here? Fx, now sigma fx has m1 ax, okay? m1 ax. Because the only m1 moves in the x direction, okay? But here, T2, okay, T2 minus mg is m2 ay, okay? Here, m3 ay. Okay? All the system run in one direction. Okay? Like that. We said this M3 here moves in this direction, M2 here in this direction of y. Then we have AY and AX, you know, will be the same. Just solve for that. If we say that, what else? Okay, now we move this on frictionless. This is okay. Frictionless surface. What about the rough surface? Fk, always negative. Fs, always negative. Why they are negatives? They are against the direction of movement. Okay? If the body is moving like that, okay, then Fk is this direction. We have other forces, which is negative forces, like we have the spring. Note the spring here. Okay. If you put the force this way, okay, the spring will give its Fs is this way. It's negative. And we have that F is equal to Ks, and this we say minus Ks. S is the distance given. This is S. Sometimes they said X, okay? I think this book they said X. K is the spring factor. We give it also, this is Fs. We give it also as a negative value because it's the opposite direction to the movement. If you take the spring this way, the force of spring goes the other way. It's also negative. These are the negative forces, frictional force, Fs and Fk. Frictional forces are negative. What else? The spring also is negative. That's what we have here. Okay, so far we moved and we hanged with no movement. We make the soft surface and we make rough surface for frictionless and rough surface. Fk or Fs, okay, or has Fs and Fk. Actually, this is what we have for the Newton's law, and we'll continue. Thanks for listening, and please make that solve the solved examples. Try to solve some problems in the book, and then I wish you good luck. And sorry for just explaining without book here. It goes off. And see you tomorrow, inshallah. Assalamu alaikum.